This conference will now be recorded.
So, when you are performing a full table scan, what does Oracle do? So, the first thing Oracle does is it basically starts reading the segment header block. So, one moment, let me just start this out. Let me just start this way. So let me just load a table first and then we'll proceed ahead. So I think this is more than enough. So header block of students. So how does Oracle proceed ahead? Now let me just take a dump of this. The segment header block contains the details regarding all the extents that are allocated to the segment. So the full table scan or a fast full index scan always starts with the initial extent that is allocated to the segment and then proceeds ahead in the order in which the extents are allocated. This behavior is same for both direct path read and full table scan as well. Sorry, direct path read and DB file scattered read as well. You end up scanning the extents in the order in which they are allocated to the segment. Suppose say now I have an orders table. Orders table is updated. I mean the details regarding the orders are updated more frequently. This orders table has 2 years or 3 years worth of data. 3 years worth of data. Now, so in any retail application, in any e-retail or e-commerce, whatever it is, any retail application, you will be working on the orders which are very recent only. So most 99% of your orders will be less than 1 week old. 1 week old only. So suppose consider Amazon, 99% of the orders will be completed in just a week. In just a week. Rest of the order, suppose say 1%, will take more than a week. So your active portion of your data, suppose say this is my orders table and I have allocated the extents in this way. So much of the workload is concentrated only on the last set of extents only because the older, we are not worried about the older data. So most of my old TP operations change in the order status from paid to successfully paid to shipped or awaiting delivery. All these statuses basically are on the recent orders only. I am not worried about my old data. So in these cases, if I am initiating a full table scan, suppose say the table size is 100 gigs, my throughput is basically, suppose say 500 MB per second. I read exactly 500 MB per second. In this case, I take 200 seconds approximately or more than 3 minutes to basically scan the entire table. I start with the initial extent. So the initial extents may contain the data which is more than 2 years old. So suppose say I started at 8 a.m. By it takes approximately 8 3 somewhere around 20 seconds, something like that, to reach the high water mark information. Now we know that most of my workload is concentrated only on the last set of extents only. Now what if I started at 8 a.m. and from 8 a.m. to 8:03 a.m., 3 minutes, I had updated, suppose say 1,000 blocks which are stored at the last extents, which are stored in the last extents. So by the time I reach here, if there are two scenarios here. We know that 100 GB, in the sense if the table is 100 GB, you would eventually go with a direct path read only. Yes, direct path read, make sure that it performs an object level checkpoint at 8 a.m. Yes, all the dirty blocks related to that particular table are returned to the disk at 8 a.m. itself. Now, in these 3 minutes, there are multiple sessions that came up and then modified the data in the last set of extents. And the best case scenario is these modified blocks are present in the buffer cache itself. If they are still present in the buffer cache, and moreover, the data that is present on the disk will be a parsed image. In this case, I don't have to generate a CR block or anything like that, unless the transaction are still going on for the past 3 minutes, or I may end up doing commit cleanout. That is a different story altogether. But now, suppose say all the transactions are already completed. So, and moreover, all these 1,000 dirty blocks, in the best case scenario, all are present in the buffer cache itself. In this case, I don't face any issues. What if, due to the space pressure, Oracle database writer ended up writing these blocks? So in this case, the block level SCN will be higher than the select statements SCN, due to which by the time I came to this particular segment, I end up reading that particular block, find that SCN has advanced. In this case, I need to generate the CR block. So things get really messy in environments wherein your OLTP workload is concentrated on the last set of extents only, or the latest data. Suppose say if the table is partitioned, guys, table is partitioned. Which partition do I read first, guys? Everyone? Suppose say if the table is partitioned based on the date column, and I ended up initiating a full table scan here. Which partition do you think will Oracle start scanning?
As per the extents that the data is stored, as per the extent allocated.
Yes, Oracle scans as per the extents allocated, but full table scan on a partitioned table. Which partition does it read first?
Folder.
It's basically the first partition that is created. It will scan that, and then subsequently based on the partition, based on the creation date, it proceeds ahead. So now you need to understand, in these environments, going with the default order will not make sense. So will not make sense because by the time you reach the high water mark, most of the blocks at the last set of extents may be modified. In this case, you would end up generating CR blocks unnecessarily. And moreover, what if the data is inserted? What if the data is inserted and high water mark position is moved, guys? You know the high water mark information initially when you started reading the table. As you are reading, what if there is significant load on the database, especially the inserts, and the high watermark is moved? In this case, what do you think happens, guys? Everyone, this is a valid question, isn't it? This is a valid scenario. Everyone?
So when it will be reached, the session will also read the latest one from that.
So I'll put it in a different sense. High watermark information, even though it is moved, So new data is only present beyond the high water mark, the previous high water mark only, right? Or only the rows which are migrated. Do you get it, guys? Both scenarios can happen. So in this case, Oracle ends up reading again till the high water mark. High water mark. So the new high water mark till that position, it will basically read. I mean, these are all nonsense kind of situations you will end up with. So in these, considering these situations in mind, you can also instruct the Oracle to read the segment in the reverse order.
Yeah, Vishnu, I have a
Reverse order.
question.
Yes. Yeah.
When the high water mark, new high water mark changed, so how Oracle
Mhm.
session will be come to know while accessing that the
Yeah,
high
it will
water
basically
mark?
read. It will basically access it again. It has to mandatorily do that.
So is from starting again it will start?
No. It won't start exactly at the point where it stopped. I think it should basically resume from that position. So I'll put it in a
Okay.
different scenario so that you get the picture. So this is my, suppose say the last extent, low high water mark is here, high water mark is here. There are too many extents here. So these are the last set of extents. I end up getting the high water mark information and the low high water mark information. Now I started scanning. In the meanwhile, what happened is that many sessions came and loaded the data. Eventually, the low high water mark position will be moved to the high water mark position, and the high water mark position will be advanced even further. So, what if, so normally speaking, if you do not consider all the other scenarios, you would assume that reading till this point is enough because all this data is new data, right, Anoj?
Correct, Vishnu, correct.
But what if a session updated a row here and row migration happened and the entire row is moved somewhere here? Do you get it?
Yes, I got it.
So Oracle, we know that row migration, if it finds a NRID pointer, it simply ignores that. So all these scenarios will come into the picture, guys. These will cause unnecessary overhead. So in situations such as these, you have a simple solution to read the table in the
Reverse.
reverse order. So I'll show you an example here. So initial set of extents are 8 blocks in length and subsequently 128 blocks, 1 MB, and then finally 8 MB extents. Now, let me perform an SQL trace here. Select AVG of Mark 1 from students. This is the default order, guys. So, can you observe the block numbers, everyone? Aren't they continuously increasing?
Yes, it's in ascending order.
So, yes, and moreover, how can you basically say that I am reading in the exact order? We don't know, right? So, the simplest way to do that is, so the initial extent that gets allocated will have the extent ID 1. Can you see, notice the block numbers here, guys? Everyone? Can you
Yes,
notice?
Vishnu. Just keep on increasing.
Yeah, so I am basically, this is how you validate, guys. So don't just automatically believe anything. So try to validate everything when you are testing, especially when it comes to performance tuning, because there is a great scope for, thinking or believing that certain behavior is true, but it may not be necessarily true. So now I've read in the ascending order or the order in which the extents are allocated to the segment. Now, if I have to perform the full table scan in the reverse order, all I have to set is alter session set events 10460. Once I set this particular event, Oracle, while performing a full table scan, starts from the last extent and then proceeds ahead in the reverse order. Can you notice here, guys? The first extent is basically the last extent. Can you notice here?
Yes, correct, Vishnu.
It did read in the reverse order. In this case, reading the segment in the reverse order will not only help you avoid the extra CR block fabrication issue, but also the other issues that can come up. So this is all. One moment, guys. Let me just close the window. So unnecessary overhead, all the unnecessary overhead or unnecessary logic you can avoid this just by setting this particular event. And moreover, this event, it can be set at either the system level or at the session level. So can you set an event at the SQL level, guys? Anyone? Hello?
Sorry, can you repeat, Vishnu? What is your question?
So the event that I have specified here, I can set it at the session level or at the system level. Can I set an event at the SQL level?
No.
No, I don't think so. We can set any SQL level.
I'll put it
We
in
can
a
set.
different sense. You cannot set an event at the SQL level. You cannot set an event at the SQL level. So using a hint or something like that. So changing this will change the behavior for all the sessions if you set it at the system level, or if you are setting at the session level, scans on all the tables are affected. So even before setting this event, try talking to your, consult your Oracle support. So this is what they recommend. So try talking to the Oracle support and then finally get this done. And moreover, you may not realize this now, but I'll put it in a different sense. Every database, suppose say the database size is 100 gigs. So in any OLTP application, you will be working on only a subset or portion of your database only. This is what you call active data set or active working set of your database. So I'll put it in a different sense. Consider remedy application, guys. Everyone might be knowing this remedy application, right?
Yes.
Yeah, it's a ticketing tool.
Yes. In this case, 90% of the time you will be working on tickets only which are 1 week old, right?
Yes.
So your
Yes,
entire data OLTP operations are basically concentrated only on this particular part, right? 1 week only. So your
Yes.
active working set will be 1 week old data only. 90% of the workload will be concentrated only on the 1 week old data. This concept, reverse scanning, you can set it at the session level or even at the system level only in certain applications only, not all the applications. Not all the applications. So you need to remember that. So this can also be utilized in certain situations, not every situation. So let me proceed ahead. Till now we have seen all the factors, guys. Now we'll look at the main things that actually influence the performance of a full table scan. So we know that we have seen the behaviors. Oracle can go with the direct path read or even DB file scattered read. So if you are going with DB file scattered read, so if you have more blocks in the buffer cache, your IOPS or IO calls will increase, thereby subsequently reducing the throughput of your full table scan that we have already seen. And if your buffer cache is really busy, or if you have a buffer cache which is undersized, if you are constantly moving the blocks, bringing the blocks into the buffer cache due to the fact that it is undersized, or if you have predominantly a DML workload, in these cases, your buffer cache will be very busy. In this, so if you have to bring multiple blocks due to the fact you are performing a full table scan or fast full index scan, you will be eventually bringing multiple blocks in a single IO call into your buffer cache. If your buffer cache is too busy, or if you have more dirty buffers, then indirectly you will trigger the database writer to write these dirty blocks to the disk. Even though the DB file scattered read is a synchronous operation, indirectly due to the fact that you do not have sufficient buffers to hold these blocks, you may indirectly notify the database writer to write the dirty blocks to the disk. Here, indirectly, your performance also depends on the availability of asynchronous IO due to the fact that database writer makes use of asynchronous IO while writing the dirty blocks to the disk. So this behavior, you will understand it very clearly when I'm talking about free buffer weights.
Vishnu, one thing here, doubt. What is the
Mhm.
default behavior of DB writer when we have not enabled asynchronous IO?
It always writes the synchronous IO. Period
Okay.
64 calls on. So I'll put it in a different way so that you get to see update students. So this is one behavior I didn't explain. So set mark1 is equal to mark1 plus 1. So I'm basically updating all the rows in my table. So once the update is complete, am I basically doing any? Okay, I have a SQL trace enabled here. Okay, let it try. So I should not have done this in this particular session. Okay, let it run. Okay, the statement is complete. So ps hyphen ef grep dbw. This is my database writer. I do have asynchronous IO enabled here. Alter system checkpoint. Can you see that I am writing blocks using asynchronous IO, guys? Everyone?
Yes,
Yes, sir.
IO gateway.
See here, how many blocks did I write in a single IO call? Can you
504.
note 504? I can even write 1000 blocks also. You need to remember that. So now what I'm going to do is alter system. Yes, alter system set file system IO options. So I won't see any issues. So I'm gonna do one thing. I'm gonna connect to the database again. Once the database is restarted, I'm gonna run the same workload and then show you what happens when if the asynchronous IO is, what the hell? Okay, now it is running. Let it run. It is basically updating all the rows in the table. Once this is done, I'm going to run an strace on the database writer again. So let's see how this database writer actually writes the data from the data to the disk. Can you see all period 64 calls, guys? Everyone?
Yes, synchronous right now.
Yes, sir.
Yeah. alter system checkpoint. How many IO calls I am making this? Can you notice?
A lot of so many.
So this will not only increase your, see, this will be very slow, guys. This will actually impact your database significantly. So I'll put it in a normal sense. There are too many things that come up if you don't have this asynchronous IO enabled. So we are just looking at the fundamentals right now. So let's proceed ahead with whatever we're saying. So indirectly, so in the meanwhile, so indirectly, your full table scan or fast full index scan using DB file scattered read indirectly also depends on the performance of it, may indirectly depend on the asynchronous IO ability, capability as well, due to the fact that DB writer has to write dirty blocks to the disk as well. So finally, database, when you are performing using direct path read, you will first initiate an object level checkpoint. Here also, database writer has to write all the dirty blocks to the disk. If you have rack environment and if you are basically having DML workload running on all the instances, in this case, a session triggering a full table scan on one instance will eventually cause DLM cross instance calls. So I'll put it in a different sense. I'll show you the wait event. Can you see it, guys? Hello?
Yes, Vishnu.
Cross instance. Yes, Vishnu.
So so your processes on the current instance will have to coordinate. Basically, it's CKPT process will have to coordinate with all the other instances to make sure all the dirty blocks are returned to the disk. This can be really, so I've said yesterday, who is, may I know who is Burg 77? Hello? Hey guys, when
No
you're
idea, Vishnu.
joining,
No idea,
so
Vishnu.
so when you're joining, please use your full name. So give me a minute. Let me just send him a chat. So you need to understand one thing. If you have more instances and if you have a DML workload running on all the instances, then the object level checkpoint will take too much time. Object level checkpoint will take too much time to complete, and eventually your full table scan will, a session performing a full table scan will suffer due to this. So you need to remember this. The general recommendation is to move all your DML workload to one
A specific
instance
instance.
only. So one instance only. So moving ahead, you need to understand one important fundamental, guys. Asynchronous IO also affects the performance of your full table scan. Full asynchronous IO also has an influence on the performance of your full table scan as well. So Then what are the other factors that can have an impact? These are all the other factors that will eventually have an impact on your full table scan, be it DB file scattered read or direct path read. These scenarios can delay your full table scan performance. So, shall we proceed ahead, guys? Any doubts?
Yes, Vishnu.
So Vishnu,
So, yeah.
like as you said, for DML, we should have this DMLs on only one instance. So that means if I'm using a rack environment, so using
Mhm.
services, I should put all my DMLs to one instance.
Yeah, that is the best thing to do. That is the
Okay.
best thing to do. So, if you carefully create services, so if all the DML statements on a particular table end up on one instance only, then things will not cause issues. So the increasing the database writer processes, will it have a positive impact on the full table scan? Not necessarily, not necessarily. It is under explicit scenarios, it will help, Dhiren. So I'll talk about CPU count, working sets, and the database writers, and also the relationship between the number of buffers, all these things when we are dealing with the buffer cache. So now let me proceed ahead.
So Vishnu, one thing more. Like you mentioned that DML activity will be in one row. So the select transaction, what will be the best option? Select transaction in the same node, or we can move it to the different node in
So
rack environment?
I'll say in a different sense why insert should not be or update should not be done in different instances. Then we'll proceed ahead with the select. So suppose say I have the students table here itself. Student ID is a primary key, right?
Yes.
Hello?
Yes. Yes, Vishnu.
So I have three instances here. I insert a row here in one of the instances, suppose say student ID 1. Now in the B instance, I inserted a row again. So the student ID is 2. According to the way in which the data is organized in the index, the subsequent values should always end up in the same leaf block, right?
Yes, sir.
Data is basically stored in the ascending order. So
Yes.
subsequent values should be stored in the same leaf block. So for this insert to complete, you have to bring this block into this instance, right?
Yes,
Correct.
Vishnu.
So what if a C instance basically inserts data now? What in this case, it has to be bought here, right?
Yes, Vishnu.
Yes. Block
So
transfer will be take more time.
yeah, bringing the block is not the main issue here. GES communication, you have to find the master first. You have to
And the
consult the
block code.
global cache, GRD, find out who is the owner, then contact the owner. All this nonsense stuff will come into the picture. Do you get it? So if you
Coordination
have
issue.
to, yeah, it's not the issue, but more unnecessary
It's
traffic,
more
right?
work, more
Yeah,
coordination.
yeah. If you have to ensure good performance, you need to take away as much unnecessary logic as you can, as much unnecessary logic as you can. Suppose say if updates in terms of indexes is basically not just replacing the value. Suppose say this is my index. We know that the values are stored in ascending order. I am updating value 1 to suppose say 1000. What am I doing here? I have to insert 1000 in this corresponding place, and moreover value 1 I need to delete it, right? Update in terms of index is basically both
Delete plus
delete and
delete,
insert.
insert.
Delete and insert. So someone, I mean, Brooks, I don't know, Brooks 77, who are you? May I know your name? Hello? Okay, that's all right. So now you get the picture, right? So you are involving two index blocks here. What if in another instance you end up updating somewhere, something related here? And moreover, you have to, so there is too much work involved when it comes to the updates or even deletes, guys. I'll put it in a different sense. So we'll talk about most of these things when we're talking about indexes. You will see the true thing coming up. Now, you asked about a question, right? Select statements.
Yes,
Yes,
Vishnu.
if you direct the DML workload only to the one instance, then requesting a block is straightforward. Requesting a block is straightforward. I'll put it in that way. You don't have to, there are even here, there is a worst case scenario that comes into the picture regarding the CR generation. That is a different story altogether. That is a different story altogether. But most of the time, the amount of traffic is basically reduced. Here you are selecting the block in shared mode, right? Not exclusive mode. Do you get it, guys?
Yes, Vishnu.
So things are way more easy. I mean, you will get to see that when we are talking about RAG, guys, not now. So
But
just
Vishnu, if we'll place everything in one instance, the server resource for particular that node and the instance performance will be degrade, might be correct.
I'll put it in a different sense. My recommendation is don't use RAG. This is unnecessary now. These days, RAG is unnecessary, guys. 100%. So you may even wonder why I am coming up with this. So you have CPU counts now. A single AMD CPU or an Intel CPU, you have 58 or even 64 cores in a single CPU itself. Single CPU can support up to 64 cores. Now, if you add hyper-threading, you will get 128. And server motherboards always have dual sockets. So I'll put it in a different sense. Server motherboards usually look like this, guys. This is a quad socket. Usually you look something like this. So dual socket, yeah, something like this. Can you see the image?
Yes, sir.
Yes,
So
Vishnu.
dual socket in the sense you can have close to 128 physical CPU cores and 256 hyper-threaded cores, right? Basically.
Yes, sir.
Okay.
So each core rack, how much does it cost? You have to spend additional money, right? On each physical core rack license.
Yes, sir.
Everyone?
Yes, in servers,
Yes, correct.
So 128 into suppose say 10,000. How much will it cost?
1 lakh
It
28.
will be more.
No, check the amount, guys.
1.2 million.
12 lakhs. 12 lakh.
1.2. 12 lakhs.
12 lakh. 12
Is it
lakhs.
$1.2 million, right? With $1.2 million, I can buy 20 of these servers. So do you, I mean, I am giving you the honest thing that I know from the current market. No one is buying rack now, except only for the big banks, where there is a dependency. They are going with the Exadata now. And frankly speaking, new customers are not even preferring rack. It's not necessary. It was necessary 5 or 10 years back when the maximum number of CPU cores in a box can be either 62 or 32 only. But now you have how many, guys? You can even have quad socket motherboards in this case, wherein you can have 4 CPUs itself. 64 into 4 will give you 256 physical cores. So is it really necessary to go with the rack, everyone, these days?
But what about scalability and availability also? Might be
So,
the
But I
reason
have a
the big
question, like,
banks.
but it comes
so
to the, I am from a banking environment.
yeah,
Okay, once it
I'll
comes
put
to
it in
the maintenance, patching.
I'll put it in a different sense. So rack, the marketing, if I am a marketing guy, I would say I can scale horizontally, but this is market stuff. If you are working really on an OLTP environment, you will see that rack is a very bad thing, very bad choice. It is basically a poor choice, guys, especially in OLTP environments. You have to model your applications based on the software feature. I mean, Oracle software services and everything. You need to basically configure your applications based on the software. It should not be the case. It has to be the other way around. That is why, these days Oracle is going down. So I'll put it in a different sense. The features should be developed based on the customer's demand, not based on the customer should not adjust to your environment. Do you get it? Hello?
Yes,
Yes,
sir.
Vishnu.
Yes.
But
Yeah.
where does it answer that scalability and reliability? I mean, like failover if we don't use rack.
So failover, I'll put it in a different sense. If your service is running here and another instance is there, so I'll put it in a different sense. And another instance is there. If this instance goes down, the marketing stuff is your service will fail over here, right? Everyone?
Yes, sir.
Yes.
Yes.
So what happens to all the active transactions and everything? Do you have to model your application based on this thing, or Oracle will automatically take care of the ongoing transactions and then it will basically recover them? One thing. Two, what if the entire cluster goes down?
Vishnu, I didn't get a chance to explore the transport failover continuity. I think
Yeah, that.
Continuity is
Damn.
there. It basically recover all the
no,
transactions.
Yeah.
they
Yes, this feature is the Oracle stuff, not the application stuff. Application level thing. Do you get it? Yeah. All you guys are basically looking from the Oracle marketing side, guys. Just come out of this mindset. Once you come out of this mindset, you will start seeing things as they are. So I'll put it in a different sense. Amazon had hell lot of transactions. Why did we intentionally move out of rack? We had to use horizontal scaling, wherein we had to basically use partitioning at the database layer, for which the application has to be modeled. The same thing Oracle copied, and then they released a new feature called sharding. This is bullshit feature. So this exact feature what Oracle Amazon used, they copied it, and then they made it sharding. I'll put it in that way so that you get to see the clear picture. Even they know that horizontal scaling is not possible using the architecture. So this is all marketing stuff. So I'll put it, so over the course of several sessions, you'll get to see the true picture. Okay, now that you have brought up this thing, how many of you think ACS actually works as intended? You might have learned. So I'll put it in a different sense. You are in for a very big surprise here. You know adaptive cursor sharing, right?
Yes, sir.
Yes.
Yes.
Adaptive cursor sharing, Oracle says in the presence of histograms, if you pass a bind variable, and if this bind variable number of rows are very high, in that case Oracle automatically switches the plan to full table scan, right? Everyone, bind peaking, everything comes into the picture, and
Yes.
then
Yes,
Oracle
Vishnu.
automatically switches the plan. How many of you guys think this will actually work? I am going to demonstrate it right away, right now itself.
Please. Yeah.
So, okay, now what I'm going to do is, so this is just a random example, guys. There are so many stuff like that. So I'm going to populate the Mark IV column using a very random approach. See here, I'm going to load the data into the table. I'm going to show how the data is present as well. I think this is more than enough. Select count of star. So I'll close all the sessions. Select count of star from students. I have close to 3 million rows, and select Mark 4, count of star from students, group by Mark 4, order by 2. So Mark 0, how many rows do I have, guys?
It's around 1.8
18
lakhs. 18
Almost
lakhs.
half, right? Almost half, right?
Yes.
So I'm gonna run small queries, select AVG of Mark 1 from students, so that Oracle ends up creating a histogram where Mark 4 is equal to 1, C.1.2, C.2.3, C.3.4. I'm gonna gather the stats here. I'll execute the things manually and then using the literal values, and then I'll show you, and then we'll proceed ahead. So flush everything out, set. I don't want even to set this particular value. So select OK and display. I did go with a full table scan here. And subsequently, I'm going to show you where is the tipping point. For value 2 also I ended up with full table scan. Value 3 also we ended up full table scan. Value 4 full table scan. Value 5 full table scan. I just want to want you guys to see the tipping point. When does Oracle basically switch from full table scan to index range scan? So I'm going to set it for 14. Even 14 is going with this. So now 20. 30 is also going with this. Yes. So did I create an index on Mark 4? I mean, that is what more stunning.
Okay, that.
One moment. Replicating this is very easy. One moment, let me just see. Sorry, guys. Bloody hell. Sorry. So, not gather stats, students. Now, let's see. I think the tipping point should be somewhere at 8 or 10 or something like that. So, I'm going to start with 8 here. 8, okay. Now I'm going to start with 4. Okay, somewhere between 5. Okay, 4 and 5. Can you notice, guys? 5 is the tipping point, right?
Yes.
Between the full table scan and the index range scan. So I'm going to show you the statistic as well. Column name. So do I have a histogram here, guys?
Yes.
Yes, Mark
I'm
4
gonna
high
gather
balance.
it also.
Yes, side balance.
So you may think that it is bad. So I'm gonna go with normal approach. I think hybrid histogram will be created here. Let it run. So top frequency histogram is created. So I do have a histogram here, right? And I'm showing you again. 5 is the tipping point. 5 is the tipping point, and 4 is where I end up with full table scan. Now I'm going to run a small load, guys. Let's see how Oracle will come up with this. So select AVG of Mark 1 from students, where Mark 4 is equal to some random value. So I'm going to randomly send the data here. I'm going to show you the SQL trace and everything so that you get to see the true picture. I'm going to have only one session executing the query. I'm going to parallelly have a single session as well. So don't trust any feature, guys. You're in for a surprise now again. Now, wait, let me run this load again. So I'm having this session running this query. So I think it did complete. Select load, select AVG of smartphone from students, and moreover, I want it to execute as much as possible. So as many times as possible. So I have this session running this SQL query. I have only one plan in my cursor cache. The two index range scan only, isn't it, everyone? Hello?
Yes,
Yes,
Vishnu.
Can you see?
yes, sir.
Now I'm going to use the bind variables very carefully. So I'm going to pass bind variables only between 0 and 8 only. Let's see how Oracle proceeds ahead here. One moment, guys. Hope you don't mind. This is my session, not explan underscore cursor 0. I'm going to perform an SQL trace on this session and then show you. SQL trace or a grep bind. I'm going to capture the bind variables that I'm going to just grab the bind variable part, guys. Let's wait. 454 26 2816 only. So one moment. SQL trace. Yeah. Can you see the bind values that I'm passing in, guys, here? Hello?
It's waiting.
Yes.
Yes, Vishnu.
Yes, Vishnu. One
Value. Can
value
you?
equal to 1. Value 5. Yes.
Yeah. So I'm going to put it in a different sense. Grep value equal to. So here we know that 4 is the tipping point, right?
Yes.
Yes.
So 1, 0 value, value 0, value 1, value 3. I have eventually executed it multiple times, but why do I still have only one cursor here? Why do I only have one plan here? I should have two plans, right? Everyone?
Yes, ideally too.
I'm
Full
talking
table and
about
index.
I'm talking in the sense of a marketing guy now. So Oracle automatically switches the plans. So how many times did I execute the query with a bind variable that should result in a full table scan? So I'm not showing or doing any marketing stuff, guys. I'm trying to show you the true things. So now tell me, ACS actually works as intended?
No.
No.
No, Vishnu.
Vishnu, a quick question. You found lot of issue in the Oracle. Have you read those SR to Oracle? and what they replied.
So when you are coming out of Oracle, do you really require? I mean, I'll tell you in a different sense. I have friends who are working as developers in the core development team itself. So optimizer core development team, they write the code. They write the code which actually makes up the optimizer. They themselves said, it is very pathetic. I don't want to say. So raising an SR, what does it help? How does it even help when the developers themselves say that the product is very bad? There are too many bugs. You get the point, right?
Yeah. Because by this
So
time, I thought that Oracle is one of the best products.
no, I'll tell you. Even now, I'll tell you, Amit. Oracle is the best among all the worst databases. So all
Sir,
databases are equally worst. Oracle is the best among all the other worst databases. So
sir, can you please check what is the value for cursor sharing? Yes, I do understand.
cursor sharing has nothing to do with it here because I'm using the bind variable itself, right?
yes, sir.
So
Right.
when I'm using the bind variables, how does it even make sense? If you want, I will change it as well. Alter system set cursor sharing parameter has nothing to do when you are using the bind variables. It has nothing to do. I'm still using the same value, guys. I'm still using the same plan. My plan did not flip altogether. My plan did not flip to a full table scan. Can you notice it? This is a real case issue or real life issue.
Actually, when we use the bind variable, at that time
Yeah.
Oracle supposed to generate new cursor plan hash value, and it will be go for full table scan as per the
Yeah.
concepts.
Yeah. You saw the
But it
practically you are seeing, right?
yes,
I'm not
yes.
doing any magic. I'm showing you practically.
So we
So
can
now
say
tell
it might be a code bug.
it's not a code bug, guys. These are some inherent things. I don't want to disclose those things, but it does not make sense. All you have to remember is it does not work all the time.
But whatever you explained, Vishnu, multiple things about rack and this all, but still I'm seeing the big organization like bank. I'm working on banks, so they are all actually trusting Oracle only.
No. Banks, honestly speaking, even if I have a bank, I will choose Oracle only. If once my turnover crosses certain limit, even I will have the license for Oracle only. I will not. I need always someone to blame to save my job, right? Our
Yeah,
banks,
correct.
I'll put it in a more proper term. Are the banks relying on certain technology, or are the managers or the CTOs actually trusting some database? You get the picture, right? The escalation line. So if a database goes down,
Yes, Vishnu.
hell lot of loss. So whom do you blame? You blame the top guy, right?
Correct.
Yeah, you get the picture now. So
Yeah, even
Sir,
I'm seeing they are
Krishna,
not
one
interested to move in
question.
cloud also. Like
yeah,
big, I'm
sir,
talking about
sir,
the big
sir, can you drop?
organizations.
Sir, can you
yeah,
please
Gautam.
drop the histograms and try running the query once again?
Try
Drop the
if I drop
histograms.
the histogram, if I drop the histogram, Oracle will go with full table scan only. There is nothing. exec dbms underscore stats dot delete table stats students. So it will assume uniform distribution if you don't have histograms altogether.
Exactly, exactly,
So in that
exactly.
case, you would
I
end
just
up
want to
seeing
see like
index
what.
scan. Okay, one moment. Gather
So,
table stats. So you are. Mhm.
no, my thought is, was it intentionally kept like this to reduce the number of parses per execution?
No,
So
no.
because we generally don't want to parse each and every time the query is being executed.
So I'll put it in a different sense. Here, in this particular, for this particular query, there are only two possible plans, right? Index scan and the full table scan only, right?
Yes.
So only two possible plans, two possible child cursors for a, see, I'll put it in the terms wherein you can understand clearly. So for a single table, 1 factorial number of, sorry, 2 factorial number of choices. So I'll have two plans. When I have two join involving two tables, I will have precisely 2 into 2, 4 child cursors, right? I can come up with 4 plans, right? 4 access methods. Do you get it?
Right. Right.
4 access
Possible
methods.
combinations. Right.
Yeah. So 3 tables.
3 factorial.
6. So even if you have 10, 2 into 2 into 10 RC, if you have 5 tables, then honestly, how many child cursors? 1, 2, 3, 4, 5. 5 will translate to 8 to 16, 16 to 32 child cursors only, right? And moreover, you have to also include the probability that not every index will have this sort of scenario, skewed distribution. So do you get it? OLTP queries will not have more than usually 7 tables involved in the join base. Usually they will not have that. So things are way more advanced, guys. I'll put it in a different sense. Don't trust any feature. Don't trust any feature. Don't be the sales guy for a product. If you want to master the performance tuning, you need to basically make your hands dirty. So you get the stuff, right? What I'm trying to say.
Yes, Vishnu.
So these are very simple things, guys. These are very simple things. I mean, I'm not doing any James Bond stuff here. So I'll put it in a different sense. I'll make this even go havoc. So what I'm going to do is I'm going to flush the buffer cache and everything. I'm going to pass in the binds now, bind values, which will result in a full table scan. I'm going to run that. So here, even after, okay, I did delete the histograms there. So let me just drop it here. So exec dbms underscore stat start. I have collected it somewhere. So let me just gather the stats here. Post which I first the shared pool. Now I'll execute the query here. So let's see the plan that Oracle comes up with. This is a right plan, isn't it, everyone?
Yes.
Yes, Vishnu.
When I'm passing values only between 0 and 4 only.
0 and 4.
Now I have a different session connecting to the database and passing the values very randomly. So I'll have 2 sessions here. 2 sessions here. So let's see if the plan changes. Did the plan change from full table scan to index range scan? Everyone?
No.
So why did
No.
the AHS didn't work? So my point is you to help you see the true fundamental ways. That's it. True things. So 9 value I should have gone with index scan. 13 also I should have gone with index scan. So all the SQL executions are going with full table scans only, right?
Vishnu, sir, I think whatever the first plan it is generating, that plan is being used by the subsequent executions, I guess.
Yeah.
In the current case, it's full table scan, and thereafter, even after the passing the values greater than 5, it is going for
Mhm.
FTS, full table scan. First, if we are forcing that to go with index scan, then it is going for index scan.
Yeah.
This is the behavior I observed.
So that behavior is also wrong again. So now see, I'm gonna flush the shared pool and everything here. I'm gonna execute the same load again. So at
Okay.
explain underscore cursor,
See,
I have index scan. Let's wait. It actually switches between the full table scan and after some time, guys. So if I add a significant delay between the subsequent executions, Oracle will
exactly.
come with the exact behavior as intended, but that also does not work as expected. So
Yes, Vishnu. In fact, I did try this feature some time back, and even tested it with histograms. I was able to clearly see the ACS implementation in place. But in my
no,
case,
it
I was
works.
not using like the Java. I mean, the sessions where the time difference between the sessions was large, like 5 seconds, 10 seconds. So in that
Variable
case, I was able
x
to see it.
execx. So this is what you have seen. Select AVJ of Mark 1 from students, where Mark 4 is equal to is to x.
Right.
This is a what the hell? One moment, guys. No, easy. So my point is, you have to test everything yourself before trusting anything. Yes. Here,
See, now
I'm
it has
gonna
gone.
change it. I'm gonna change this again. Change the point variable to suppose say 1, and I'm gonna execute it.
Now it will go for full table scan.
Where
Oh,
did
sorry. No, sorry, not index. No, can you please force that to go with index FTS now?
it? If I force it, what is the point? You get the
Yes, yes.
picture, right?
No,
So,
if you are forcing, then we are not even using the ACS feature.
one thing,
Right.
guys, don't actually, I mean, I don't want to stress things over and over again. So, due to the fact that you have been exposed to hell lot of stuff in the blogs and the blue books, which are written by the prominent authors, which, and moreover, these are marketing stuff. Do you get it?
Sir, what is your opinion on Tunnel Powder?
Daniel Porter is a very good guy. Yeah, he is a very good
Okay,
tuner.
okay.
Why did you ask that?
No, I just wanted to see like what is your opinion on them.
No, Daniel
I,
Porter is a different guy now. See,
okay,
even he and me, we are both on the same page. We are not into Oracle anymore. Oracle is just a side thing.
okay. Mhm.
He has his own company. I have my own set of companies. You get to the picture, right?
Right, right, right. I'm getting it.
So, and moreover, there are too many things involved here. So, see, I'll put it in a different sense. Yes, a DBA who writes the blog will be seeing things only from his perspective, not from all the perspectives. Do you get it?
Yes.
So it may not work all the time. It may not work all the time. So this is a simple scenario where I have shown you things. So we did waste almost 15-20 minutes on showcasing something that is pointless. I mean, we could have discussed this later point of time. So you just took the surprise at that particular time. So I'll put, so I'll say in a different sense, guys. If I have a business turnover of 1 million per month, I would go with Oracle because I can rely on Oracle. Despite its flaws, I still trust Oracle. I still trust Oracle. Personally, I will someday actually buy Oracle license. Right now, all my data centers are going with Postgres only. Just because I am
Okay.
not able to afford 50K per CPU core, I cannot spend this amount. So 50K in Indian terms is how much?
50 into 70, 35
Yeah,
lakhs.
yeah.
into
35 lakhs. Two CPUs, I can buy a BMW here.
Right.
Do you get it?
Right, sir.
So that is a different story. If I have started my business in US, I think I would have started. I would have bought Oracle by now. So that is a different story. So let's proceed ahead. 10046 tries, guys. So you have to remember one thing. If the blocks are already cached, suppose I'll put it in a different. I'm going to close everything out, and I don't want this Eclipse to be running the workload as well. So SQL trace will not give you the entire details all the time. So why is it still running? Okay, now at active, I'm going to run an SQL trace here. So few guys, I actually, I mean, like in Oracle or Tunnel Powder, and basically that Richard Foot, only two guys. And then previously, Earl Schaffer is a guy, guys. I mean, that guy used to be my mentor. That guy used to be my mentor. He passed away a few years back. So only these guys. I mean, that too. If I mean, I read their blogs, but I don't test their blogs. I mean, test the content in their blogs. All the others, I'll test it. So I'll put here. I'm gonna execute a small query here. I'm gonna flush everything out. Select AVG of Mark 1 from students, where Mark 4 is equal to 1, 2, 3. Can I see the writes, guys? Reads, everyone?
Sequential read. Sequential read.
If I execute the same statement again, did I see any wait events logged?
No.
It is
Only
because
one
the blocks are
in
already stored
buffer
in my
cache.
buffer cache. It is because the blocks are already stored in my buffer cache. So I don't want this cursor sharing. I reset SP file, I just basically reset everything out, guys. So I'll just show you that as well. So you might wonder that I might be showing you stuff. So these are all default parameters, don't you think, everyone?
Yes, sir.
I'm not having any hidden parameters also. I'm not controlling anything. So whatever I'm showing you, you can test and replicate also. So coming back, 10046 trace will not give you all the details. So if all the blocks are cached in your buffer cache, you will not have the details. You will not have the details. So if all the blocks are cached, if you are trying to generate a CR block, in this case, these details are also not shared properly. You will not see these details properly in many cases. Instead, rely on $sestat view to get the precise number of blocks which ended up with CR generation. So many things you won't see, guys. So don't trust the 10046 all the time. So if the even though if you are making an IO request, what if the data is cached in the SAN layer? In this case also, you will not see the wait event logged there. So don't rely on 10046 all the time.
The only
All the
problem
time.
here is it's cumulative wishes, sir. VDOLA
Yeah.
session stat.
So
You'll
sestat
not
is a
get the correct
cumulative.
figures.
Yes. Yes, but you have once you start using it, you will slowly. I mean, it's all this thing is. If I execute the view against the $V sestat subsequently, suppose say 2 times or 3 times, I'll get the difference, right? That difference is enough for me to, actually enough for even you guys to basically see what is going on. So it takes time. It takes time to see the things more clearly. So now let me proceed ahead with a very basic example, or I'll introduce the concepts regarding the ITL slots. So everyone, are you actually feeling things more different than what you have learned till date? Everyone?
Yes, sir, definitely.
Yes, we are experiencing
Lot more.
reality.
Yes,
We are
actually,
seeing the
Yep. Yes,
how practically we have to work, how to things we need to check. Now we are learning that in that path we are going.
sir. One
So,
question.
Mhm.
If the blocks are in my PGA session PGA, then also I'll not be able to see proper things from 146 race, right? Or is it
when
otherwise?
the blocks in the PG,
Yeah, when I'm reading the full table scans or whatever the things.
so I'll put it in a different sense. PGA contains intermediate data only. Apart from the full table scan, all the
Mhm.
other operations, you will have only the intermediate data only, that not to the entire block details, block data. So I'll talk about that in the in-depth, in-depth in the later sessions, guys, not now. So you guys are becoming too, curious.
Okay.
So be curious, but not, let me complete. If it is not, 45 days, we
Sorry.
cannot complete it.
Oh,
So
sorry, sir.
I'll talk
Sorry.
about
Carry
the
on.
concepts regarding the ITL slots, guys. So let me just show you in a specific way. So I'm gonna clean up everything that I have here. Clean up. I'm gonna clean up all my tables and everything, all my schema. Now you can see the script also, guys, what it does. It just drops the table, that's it. So I'm creating a table here. Create table. Suppose say Burku 77. I don't know who he is, so that's why I'm using his name. So roll number, name, warcap 230.
It is stored in
So
the database.
so I'm going to load a data into this particular table. Values 1, suppose say 123. Commit it. Commit the data, flush the buffer cache. So now everything is done. So in the same session, what I'm going to do is, even before proceeding ahead with the insert statement, I'm going to switch the log file, alter system, switch log file, insert the data again. So this is my entire name, guys. I'm gonna insert the data. So so I'm gonna insert the data here. I did insert the data. I'm gonna commit this transaction. I'm gonna switch the log file again. So select group hash status from $log. Select member from $log file where group hash. So I'm going to show you the exact order in which Oracle used. Alter system dump log file. This is the trace file related to that particular redo log, guys. So the entire data is basically present here itself. I'm gonna just copy this, or basically I don't, okay, I'll just have this here. And in another session, I'm gonna show you 346 is the CR block generated. Where did it basically insert? Let me just insert the same value again. Now the touch count should increment. Yeah, I think this is the data file, data block. So dump block 7 351. So this is my ITL portion. This is my ITL portion. So let me just copy it off here. I'm gonna switch the log file one more time.
How do you find which is the related trace file? Can you show that one more time?
Last trace file, that's it.
The latest timestamp. Latest
Yeah.
timestamp. Latest timestamp.
Yeah.
Sir, by
The
default, ITL
LSAT.
would be two, right?
Yeah.
By default, ITL slot would be two, right?
ATL slot.
Would
One
be
moment.
the value would be 2, right?
One moment. One moment, man. You're asking something in the middle. I'm getting confused. Please
Oh,
wait.
sorry, sir. Sorry.
Please wait. Let me get the relevant data here. So there are two things you need to remember, guys. So when you are dumping a data file, when you are basically dumping a data file block, when you are dumping a data block, Oracle, first thing what it does is it dumps the in-memory version first, and then it dumps all the CR versions if you have any CR versions of the block. Then finally it dumps the on-disk version. So let me just show you that once you are dumping a data block. So here I am dumping the data block here. So first thing it dumps is it dumps the data from my buffer cache. Then if I have any CR blocks, then it dumps the data from there, and then finally it dumps the data from the disk. So if you want to see the latest data, you should always see the data from the dump or the section of this trace file which contains the details regarding the dump of the trace file itself. Sorry, dump of the, what do you call that? In-memory version itself. So,
Buffer cache.
buffer cache itself.
Exclusive
So
path.
now, yes, now let me take this particular trace file here. I think this is the transaction that relate to my thing. So I have to compare a few things here. Mm, yeah, this is it. So I'm gonna just copy this thing here. So I'm not going to use this, guys, block cleanout. I mean, this change I'll explain in the later sections. So for now, just I'm gonna take this part itself. So whenever you are trying to modify a data block, what is the Oracle's path? How does Oracle proceed ahead? So whenever each time you need to modify a data block, Oracle has to first add the ITL entry in the data block header. Without adding the ITL entry, Oracle cannot proceed ahead. So even before modifying the contents of your data block, you need to add an ITL entry in the block header. It is only after you add the ITL entry you are allowed to modify the data in that particular block. It is only after you add the ITL entry. So to add the ITL entry, you need the transaction ID details. You need the details regarding the undo block, which contains the necessary rollback information as well. So a ITL slot contains the transaction ID, undo block address, or the block undo block, which contains the necessary rollback information, and you will have the SCN flag, etc. So you need to understand one thing. To get these details, basically what do you do, guys? Let me show you in terms of redo here. So how did Oracle proceed ahead? How did Oracle proceed ahead? Let's look at the changes that Oracle made in terms of redo. So the first thing, you have to add the transaction details in the ITL slot. So basically you have, sorry guys, you need to have, you guys actually asked me a few questions and then I missed the flow now. So let me just try to recollect it. So first thing what you do is when you are trying to make a transaction, you need to add the transaction details in the undo transaction table. So here, this is the undo transaction table block. So here, can you notice this guys, everyone? You need to basically add the details in the undo transaction table first. Then you add the corresponding rollback information in the undo block. So I am seeing an echo, I am hearing an echo guys. Please place your calls on mute. So now, can you see the undo block address here guys, everyone?
Yes.
It is after, it is post I add the data in the, it is post I add the data in the undo transaction table, corresponding undo information in the undo block. Then I will add the entry in the block header. Then post which I will modify the table data. Observe the, so the changes performed may not necessarily be the exact order. So notice the SCNs here, guys. SCN at which this change is performed. Can you notice the SCN here? Everyone?
Yeah, yes, Vishnu.
You added the entry in the undo table first, undo block first. You added the necessary rollback information in the undo block first. Then once you added it, then you add the corresponding details in the undo transaction table. So here in an undo transaction table, you also need to have the details regarding, you need to add the undo block which contains the necessary rollback information. So this part actually, can you see this particular column guys? Everyone?
Yes, sir.
Yes, yes, Vishnu.
So the process is basically this case. Once I insert or perform a delete or update, whatever it is, first thing you need to generate the rollback information. You add that rollback information in the undo block, get this undo block details, add the corresponding transaction details, transaction related information in the undo transaction table. Once you get the, once you have done this particular stuff, then you add the ITL entry in the table or the index block header. Once post adding the ITL entry, then only you are allowed to modify the contents of this block. If you cannot add an ITL entry, in this case, you will end up with NQITL
Wait.
alloc wait event.
Wait.
So it is only once you add this ITL entry, then you are allowed to modify the block. So here, observe the flags here. This transaction is committed. See, LCK part indicates the number of rows locked by this particular transaction in this block. In this block only, how many rows I have logged. So it is post insertion. Once I commit this transaction, once I commit the transaction, the session, what it does is it revisits the block again and then clears the flags or updates the ITL portion saying that the transaction is committed. Can you notice here, everyone? I'll
Yes,
explain
sir.
things in very simple way, so that you get to see a clear idea. So I issue a, give me a minute, yes. So I issue a DML statement. The first thing I need to do is add the corresponding rollback information in the undo block, then add the entry in the undo transaction table, then add the ITL entry in the table block header, modify the block. Once I modify the block, my insert statement processing is complete. As soon as after certain time I commit this, I issue a commit, then this session, what it does is it revisits this block and updates the ITL slot, saying that the transaction is successful. It also updates the transaction table as well. So this is all unnecessary stuff for now. Just remember that post
Yeah,
commit.
Vishnu, one question I have. Why we need entry in ITL slots?
You need to ask
Avoid
Oracle.
to avoid data corruption.
No, I'll put it in a different sense. That's the architecture. That's it. Just remember that it has an architecture. Why? Yeah.
Sir, basically that is to avoid data corruption, right? Where if there is no
No,
ITL
I'll
entry
put
made by
it
a
in a
session.
different sense. I'll put it in a different sense. He asked a valid question. So, what if I cannot basically visit this block post committing the transaction? What if I cannot access this block because this block is pinned by a different session? Do you get it? Or if this
Yeah.
block is written to the disk by the database writer due to the space pressure. In this case, I need to read this block again, right?
Yes.
So insert statement itself, I am inserting, modifying. So the insert statement, how many blocks I am basically touching here? Undo block, undo transaction table block. These two blocks are different. Then the table
And
block.
table block. Table block.
I haven't added any indexes here because we are not talking about indexes here. So I'll skip that part for now. Then post committing the transaction, I have to basically update the transaction table and moreover the table block as well. Here, what if this block is pinned by a different session? Then in that case, your session has to wait until that particular block is, until the other session releases that pin. So this is all unnecessary concurrency. Or in worst case scenario, what if the database writer writes the block to the disk? I have to read that block again, right? To read that
Yes.
block, I need to find a free buffer again, right?
Yes.
Anoj, can you see the picture?
Yes, Vishnu.
So these are all unnecessary overhead. So you have to remember that ITL slots, whenever you are modifying when you are modifying the block contents, be it a table or an index block, you need to add an ITL entry. ITL entry can also be used by other sessions to identify whether if there is any ongoing transaction or not. If you are reading a particular block, Oracle, the first thing it does, so be it an insert, delete, or update, or select, the first thing you do when you access a particular data block is read the ITL portion and see if there are any ongoing transactions or not. You have to first access the ITL slots and then proceed ahead.
Okay, so ITL in the makes sense. It's mandatory to manage the consistency between the multiple blocks which are getting changed at the same time.
Don't go that don't go to that way. There is not needed. So I'll put it in a different sense. You don't have to dig that deeper. Just remember that ITL slot, you need to add an ITL slot each time you modify a particular block. And whenever you are accessing the block, you check the ITL slot to see if the transaction is going on or not. That is the only thing you have to remember. All the additional stuff is nonsense, or I'll put it in a different sense. You cannot do anything with that knowledge. You get it, right? Everyone?
Yes, Vishnu.
So now, coming back to my original slide. So an open ITL slot can be of two reasons, guys. There are two reasons why slot in the ITL slot can be open in the block header. One, it is due to ongoing transaction. If I'm making a large transaction wherein I am basically updating too many rows, in that case, I'll have that slot open till I finish that particular transaction. This is one scenario. The second scenario is session sometimes cannot clean the ITL slot post commit. This can be due to several factors. One thing is, simplest explanation is database writer writing the block to the disk. This is the simplest explanation. But there are also cases wherein if a block is pinned, in that case also, if the block is pinned by a different session, in that case, instead of waiting for the session to unpin that block, this session actually gives up on clearing the ITL record. Do you get it, guys? This is also
Yes,
a
sir.
different scenario.
Vishnu, I have one question here. Like when DB writer is writing the block from the DB buffer cache to the file system disk, so it will write the whole block. Otherwise, it will just write the excluding the ITL content, ITL that session.
So database writer basically writes the block. That's it. It writes the entire block. Why should
But
it
in that,
exclude the header? It will write the entire block. So I'll show you a simple scenario. So I
no, I
think
got it.
today's
But
class will extend.
my doubt is like if it is overwriting the block entirely, ITL like
Yeah,
whatever the entries that ITL has, it was also overwritten, right?
ITL entries will be overwritten. Yes. I'll put it in a different sense. So I'll show you in terms of this thing, outer system. So this is very important. If you are to reach an architect level someday, so you have to understand how things actually work. I believe at least 10 or 20 people of you will become an architect someday. Others may even move to a different field, we don't know. So I'm just trying to show you how exactly Oracle does that. So now I'm going to load some data into small table. So 10 sessions, insert load. I'm going to create a table and then load it with data. So ES-F grep dbw strace -p ss filter system checkpoint. So am I writing the entire block or just the part of the block, section of the block? Mahendra?
Entire block.
Everyone, can you see it?
Yes,
Mahendra,
Vishnu.
right?
Yes, sir.
Mahendra or someone asked? Narendra or Mahendra?
Narendra.
Narendra, yeah. Can you see the entire right? Is it writing only certain section, or is it basically overwriting the block that is present on the disk? It's basically overwriting the content itself. So it writes the entire block. It just basically dumps, copies the block. I'll put it in a different sense in programming terms. It just writes the contents of the buffer to the disk. It just dumps it directly. That's it. So coming back here, my pen. Yeah, a session can also fail to clean out the ITL record post commit. It can be due to database writer writing to the disk, or if there is any session also pinning this particular buffer also. In those cases also, this session fails to clear the ITL slots. This is to improve the concurrency, or improve the transactions rate. So don't think that this is a very flawed approach. This is in fact the best approach to increase the TPS, transactions per second at the database level. So I'll put it in a different sense. The number of transactions that you can attain using the Oracle database is way more compared to Postgres or MySQL. Oracle can give you 10 times or even 20 times. So don't think it as an disadvantage because the other session may end up clearing the ITL record. So don't think it that way. This is a very good optimization, and moreover, it is in very rare circumstances that a session may end up not clearing the ITL record. So now let's go on, proceed ahead. So if I have an open ITL record, due to the fact that a transaction is going on, in this case, what happens? Let me just show you that. So I'm going to show you in a simplistic way, guys. So I'm going to close all these sessions out. Home DB. I'm going to clean up all the tables. Create table temp, roll number, primary key, name, varchar 2 of 20 or 30, whatever it is. So I'm going to insert a row into this particular table. Insert into temp values 1 comma issue commit. Now I have committed the transaction and everything. So I'm going to insert a different row here to suppose say what name, Veronica. I don't know who she is, but I'm just simply using the name. So now using a different, I'm going to show you the contents of my buffer cache base. So all are xcur or the current version of the blocks only, right?
Yes.
This is the table and this is the index. Now in a different session, I'm going to run a statement select star from temp. I have an ongoing transaction here. What happens? Can you notice a CR block generated case?
Yes, sir.
It is when I am basically accessing a block, when I am trying to read a block, I have to mandatorily look in the ITL section. If I find a transaction ITL slot open, and if it is basically open, if a ITL slot is basically open, it means that the transaction is going on. So Oracle, this session, what it does is, it basically reads the undo transaction table to see if the transaction is in progress or committed. It does not know just by looking at the ITL record. So it could be also due to the fact that the initial session may have failed to clear the ITL slot. So in this case, Oracle, this session, what it does is it reads the undo transaction table to find out whether the transaction is committed or not. So in this case, the transaction is not committed. So I have an ongoing transaction. So Oracle, what it did is it basically cloned this particular buffer and applied the rollback information obtained from the undo block address. So now I'm going to issue the same statement again. You have to understand one important fundamental here. Every statement that you issue select statement has an SCN associated with it. Every select statement, so when you execute a particular select statement, to ensure consistency, Oracle should retrieve the results according to the exact time at which you executed that select statement only, to ensure the consistent results. So to ensure that consistency, I mean here the SCN has advanced at the database level. I end up executing the SQL statement. The SCN of this particular execution is different now, different from all the CR blocks that are already generated, due to which Oracle ends up generating an additional CR block again. Can you notice, see this guys, everyone? Here a transaction is still going on. That's the reason why the transaction is still going on. That's the reason why I ended up generating a CR block. What if the transaction is committed and the previous session did not get the chance to clear the ITL record? So I'm going to simulate that behavior here. So the transaction is still in progress. So I'm going to insert a different row again here. Post which I'm going to flush the buffer cache. Once I flush the buffer cache, Oracle basically writes all the dirty blocks to the disk and then marks every block as free block. Now, if I commit this transaction, this session will not read the blocks from the disk and then clear the ITL record. Instead, it basically gives up on clearing the ITL record. So subsequently, now let me just show you the states here. So state is free in the sense the block is it's not present there. So now I'm going to execute the same statement here again. So on disk version of the block, I am reading it. Now, can you see the dirty flag set, guys, here? Everyone, can you see the dirty flag? The select statement, what it did is it read the ITL portion. It found out that there is an open ITL slot. It went and checked the transaction table. Then it found out that the transaction was still in progress. Sorry, the transaction has committed. Then it performed a commit cleanout. In this case, I am modifying the ITL entry in the table header. So I'm gonna just dump this file and then show you the details. So dump block 7. So let me just show you the ITL portion on disk version and in memory version as well. So this is the on disk version of the block, wherein the session did not clean up the ITL record. In memory version, sorry, where is this thing is? This is the in memory version. So post commit cleanout. Can you notice the difference in the ITL entries, everyone? Can you notice the difference?
Yes, sir.
A select statement, what it did, it ended up modifying the block by clearing the ITL record. Here, this is the reason why select statement generates redo also. I'm modifying the block content here. So that is the reason why I end up generating redo. Do you get it, guys? So the commit cleanout happens especially when the session which initiated the transaction gives up on clearing the ITL records due to the fact that database writer has written the data to the disk, or if any other session has pinned that particular buffer. So in that case, it gives up, and the subsequent session which actually tries to access that same block will clear the ITL slot. So this session clearing the ITL record, this process you call it as commit cleanout. So as soon as a session finds an open ITL slot, it reads the undo transaction table. Then it basically reads the undo block, which contains the relevant undo information. I mean the rollback information. This process is when there is an ongoing transaction. So you have to remember, guys, ongoing transactions and commit keynotes can be seen more often when you are performing a full table scan, be it DB file sequential read, DB file scattered read, or direct path read as well. So we are going to extend this class session. I mean, I still have only 4 slides to explain, guys. So we'll finish it off and then we'll wind this session up. So due to that ACS part, we took more time here. So now let me proceed ahead here. So when I'm performing I'm talking about in the context of only the ongoing transactions here. I'm talking only in the context of ongoing transactions here. So DB file scattered read. So I don't know who, but I'm actually hearing an echo, guys. Are you in a conference room or something, Gautam? Gautam
No,
or
sir.
Aish or something? Yeah, okay. So please put your calls on mute, guys. So DB file scattered read. I am performing a full table scan or fast full index scan here. So if there are any ongoing transactions, each time I access a particular block, I end up looking at the ITL header. So if the transaction is ongoing, I have to generate a CR block. In the context of DB file scattered read, which is a buffered read, to generate a CR block, I need to find a free buffer to clone this current buffer. Do you get it, guys? If I have to fabricate a CR block, I need to find a free buffer or a buffer to replace the contents, right? I need an additional buffer here in the buffer cache. So this can affect other queries as well. This can affect other queries as well. I'm talking about here in the current terms of worst case scenario, where in worst case scenario or even in a normal scenario, if you have huge DML workload. So if you have, suppose say, if I have 1,000 blocks which are modified by a previous session and this transaction is still going on, or if the previous session has not yet committed, in this case I would end up generating 1,000 CR blocks in the memory. So the latch activity also increases considerably. Latch activity also increases considerably. You have to remember that CR blocks, all the CR versions of the data block or an index block will be present in the same hash chain. I'll talk about the order and everything in the later sessions, but you have to remember that to find a free buffer, you need to walk along the LRU list. Once you find it, this block may be part of a different hash chain. Do you get it, guys? Everyone?
Yes,
sir.
sir.
So this block may be
sir.
part of a different hash chain. If you have to remove this particular block and then bring it to this particular hash chain, you need to unlink this block, right, from that particular hash chain, then move it here. So, and again, add it, link it here. I mean, there is too much LRU, and then the CBC latches also will be there. So latch activity will become too high, guys, if you have especially more number of blocks, I mean, with ongoing transactions on it, or in the worst case. So I'll talk about the next thing, commit keynote part later on. So what if the transactions are already committed? So now this adds up a different scenario. So now the table size is 1 GB. Already the blocks are cached in the buffer cache, by the time I reached 900 MB, the other blocks, the rest of the blocks are modified and the transactions are also committed. In this case, the SCN at the block level will have advanced. If the SCN at the block level is high, if the SCN of the block is higher than the select statements SCN, in this case also I need to generate a CR block. So
Right.
it's not just the ongoing transactions, it's also when the transactions are committed and the SCN at the block level has advanced. Both the cases I end up generating the CR blocks. So I would say, considering the CR mechanism and everything, Postgres is way better than Oracle when it comes to this handling of CR blocks case, because the rollback data is present in the current block itself in Postgres. So Postgres is way more robust compared to Oracle when it comes to the CR handling. CR handling in the sense, in terms of how do I put it? In terms of the design itself,
Undo
it's
management.
very good. Yeah, undo management, it's way more sophisticated. It's not sophisticated. I'll put it in a different sense. For climbing up the wall, all you need is a ladder. You don't have to go bring the crane, sit in the crane and then push your button. All this nonsense is not necessary. So I'm not talking about all the cases. In certain workloads, Postgres handles way better. So now going to direct path read, I think the screen is not good. So let me just bring the thing here. So direct path read here, guys. So direct path read, inherently I have already shown you. You need to basically perform an object level checkpoint initially. You need to perform an object level checkpoint even before commencing the full table scan. Due to this object level checkpoint, the database writer may end up writing the blocks which may contain ongoing transactions also. Especially this happens when the table is mutating or the data is changed more frequently, if there are any DML statements occurring as well. And if the application do not use auto commit, this is also one thing you need to remember, guys. So application sessions or the Java sessions has the capability at the application at the code level itself. So I'll put it in a different sense. I'll show you precisely so that you know things clearly. So here I have the connection here. I can set at the connection level whether to commit the transaction or not, or whether to commit the transaction automatically if I issue a DML statement or not. Do you get it here, guys? If I use auto commit, the chances are very less. Chances are very less when it comes to the ongoing encountering the ongoing transactions. For both the cases, if you use auto commit at the application layer, the chances are very less. If you are manually committing the transactions using oracon.auto, so I'll put it in different sense. So I can manually commit as well. If I'm manually committing, then there is a chance for, then there will be chances for ongoing transactions. So you need to remember. So auto commit, there will be less chance. So now you will end up having uncommitted changes written to the disk as well. What if the transaction is still going on? So the database, your session ends up reading the data from the initial extent by the time it reached the last extent. Suppose, say, one scenario here is the session is still performing the transaction. Session is still performing the transaction. In this case, what happens? I read the data into my PGA. As soon as I read, I access the block contents. I first initially look at the ITL portion. I find that transaction is going on. I find that the transaction is still going on. In this case, I have to fabricate a CR block. This CR block fabrication happens at the PGA level itself, in the PGA itself. So CR blocks are generated in the PGA itself. But during this process, if the corresponding undo blocks are not there in the buffer cache, you bring these, you read these undo blocks using DB file sequential read, and then you bring these blocks into the buffer cache. So this is one scenario when the transactions are still going on. What if the transactions actually committed? You have to remember one thing. I end up performing an object level checkpoint before commencing the full table scan. So as the best case scenario is the sessions after the post the object level checkpoint, the sessions end up modifying the data in the table. If the data is still in the buffer cache, the full table scan is not affected. But these transactions, if they are committed, and moreover, database writer ended up writing these blocks to the disk, then this also leads up to the CR block generation because the block level SCN has advanced. The CR blocks also are generated at the PGA level itself. So this is the thing, guys, regarding the ongoing transactions. Now, similarly, the case with the delayed commit cleanout. So when you are performing a DB file scattered read, you bring the blocks into the buffer cache. You find that the transaction is still going on. ITL slot is basically open. In that case, you read the undo transaction table, find that the transaction is committed, and then you clean that particular ITL slot. So here there are too much activity involved, too much things actually involved. So this delayed commit cleanout, you can see the sessions doing this more during full checkpoints. If your log file sizes are not properly set, and if your database is frequently frequently performing the checkpoint, and also your sessions are not using auto commit, then there will be great deal of this thing coming up. So you need to remember that. And delayed commit cleanout, when it comes to the DB file scattered read, you end up generating redo as well. You end up generating the redo as well. So here the transaction is already committed. In this case, there is no need to read the undo block which contains the corresponding rollback information. There is no need to read this undo block. You just read the transaction table block, find out whether if the transaction is committed or not. Once you find out that the transaction is committed, you simply proceed ahead. So there is no need to read the undo block because you are not generating a CR block here. There is no need to generate a CR block. So now things get, so these situations can be very tricky, especially with direct path read. So I'm going to simulate a small behavior here. So I have the table here, so I don't want to mess with these things here. So hardly 10 minutes, guys, we'll wind this up. So I'm going to load some data into the table. 4 million rows, this is more than enough. I'm going to close all the sessions up. I'm going to simulate a small behavior. Alter system checkpoint update students set mark1 is equal to mark2 where student id less than student id greater than oh god, I should not have committed it. One moment. I just have to show this particular part here. So checkpoint. So mark 2 plus 1 where student ID now I'm going to open up a different session, guys. So this is to simulate. I don't even have to do commit or anything. You can just run this particular statement. I'll just leave it as it is. Here the transaction is still going on. Now in a different session, what I'm going to do is, this is my this is my SID. So in a different session, I'm gonna show the statistics as well. Select a of name, b dot value from b dot stat name of a, b dot systat of. So I'm gonna share both the morning and the evening sessions as well, guys, for this today's recording. And a dot name like so. Let me just execute this particular clean out. So I'm gonna do one thing. In this different session, I'm gonna force this to perform a full table scan here. All the session set serial directory is equal to always select AVG of mark one from student. So now understand, guys, the transaction is still going on. The data is dirty. Now this select statement, due to the fact that I am forcing it to go with the direct path read, it performs an object level checkpoint, which results in writing these dirty blocks to the disk, which contains an active transaction on it. So I'm going to commit this. I'm going to run this. So now let's see the statistics here. How many cleanouts and rollbacks did I have to perform this? I had to basically read the data from the disk, then into the PGA. Once I found out that there is a transaction going on, I had to basically create a CR block. Can you notice, everyone? Hello?
Yes, Vishnu.
So this is one thing you need to remember. So I
So
think
CR blocks are created in PGA?
yeah, CR blocks are created in
Yes.
PGA, not SGA. In this particular case. Now I'm going to commit this transaction here. So guys, please, Abhishek, can you please put on? So Abhishek, I cannot put you on mute. Okay, yeah, I just muted him. So now I'm flushing the buffer cache, guys. So to simulate that this session cannot perform a commit cleanout. So now the transaction is committed. Now I'm going to execute the same statement in a different. I'm going to execute this. Let's see how many cleanouts I'm making, guys. Can you notice that I'm performing the cleanouts, everyone?
Yes, 913.
Yeah, even though the transaction is committed, each time I access a block, due to the fact that the ITL portion of the slot, ITL slot actually indicates that the transaction is still going on, I have to mandatorily read the undo block and then see, clear the ITL slot. So I'll put it in a different sense. See here, the data is present on the disk. Data is present on the disk, and the table blocks has an open ITL slot. The transaction is committed. But the session which initiated the transaction did not clean out the ITL record. So on disk version will always have the ITL slots which are open. Due to this and moreover, direct path read, you are reading the data into the PGA. You end up cleaning out the ITL records over and over again. This happens infinite number of times until these ITL records are cleaned or the flags are set saying that the transaction is committed. Until the time any other transaction reads these corresponding blocks into the buffer cache, you will have these ITL slots open on the disk, on the on disk version of the block. So now I end up performing the cleanouts any number of times. Can you notice here, due to the fact that on disk version of the block has an open ITL slot. So now, what if another session comes up and then performs a commit cleanout? So what I'm going to do here is, in this particular session, I'm going to force it to read the blocks into the buffer cache.
Buffer cache.
Now, what happens is that once I read these blocks into the buffer cache, I end up performing commit cleanout. I will perform the commit cleanout. Due to the commit cleanout, all these blocks will become dirty. Now, this session, which is basically performing the full object level checkpoint, will end up writing the cleaned out, the blocks with cleaned, ITL records cleaned onto the disk. So only one time you will see this thing actually happening. The second time onwards, so one moment. Serial direct read is never. One moment, yes. I think there is some other thing that is coming up. So I'm gonna, once this is done, I'm gonna do this. So subsequently, you will not see this cleanout happening, yes. Subsequently, you will not see this cleanout happening. So in this case, there is something weird happening on. So I'll do one thing. So as soon as I bring these blocks into my buffer cache, session will actually perform a commit cleanout. Then these blocks will be flagged as dirty, and the subsequent time when this particular session performs a direct path read, all these dirty blocks should be returned to the disk, post which once the ITL records are cleaned, I will not see. Can you see this not incrementing, guys? Now, everyone, even though I'm
Yes,
executing the full I'm using the direct path read, this is not incrementing. So this is an inherent side effect, guys. This is an inherent side effect. So you may have a block with, due to the, if you have in Exadata environment specifically, if you are going with smart scans more often, this is an inherent side effect. This is an inherent side effect. Yes, the Exadata marketing thing has something called, come a cache layer, active transaction cache layer at the Exadata cell layer, but remember, it does not help always. It does help in many cases, but not always. So now that you have seen the two effects, now I'm going to show you a different thing here. So these statistics are very helpful, guys, at this session level to see whether if the session is performing CR block generation or it is just cleaning out the ITL records. These statistics are very handy. So now let me proceed ahead with a different fundamental. Only two things left out, guys. We'll wind up this session. So what happens with the chained rows, guys? So I just told you, I have shown you one aspect of the chained rows only. So chained rows actually does impact your full table scans. It's not the migrated rows, it's basically the chained rows which actually does have an impact on your full table scans. So let me just load the data into a table, and moreover I'll create the chained rows. So So, my honest suggestion is try practicing everything. I have given you the best case scenario wherein I have, gave you the code, necessary scripts and everything, guys. Try making use of it to the best extent. So test every possible scenario. That is when you get to see the true stuff. So now let me load some data into this table. Hello, can you see? Hello, guys. Can you hear me?
Yeah. Yes, yes.
Yes, sir.
Bloody hell, my CPU got hung. I need to restart it. Yeah, it's hung, man. It's hung actually. Let me just restart the machine. So it's basically hung. So in the meanwhile, it takes at least a minute to bring it up. So do you want to extend, or I mean, the morning session I have covered both the chain rows and the details regarding the fragmentation. Is it good for you guys if you can see the video, or do you want me to explain this as well? Do you have the patience, guys? Already, I mean, 10 people have already gone.
I think it's better you just share the video, morning video, because too late.
Yeah, it's already too late. So I'll do one thing. I'll try. I mean, the content is basically the same, guys, especially related to the chain rows and the fragmentation part. I'll try sharing that. So instead, I think, let me see. Let me just show you how actually this thing works. Works in the sense the go-to meeting. I'll just share those videos with you. So one thing is change your mindset in the sense, I'm not saying it in a sarcastic way, but I'm trying to tell you that, you have been looking at things in terms of a marketing guy's perspective only, not in terms of real stuff. So try testing everything out, guys. Try testing everything out. So let me just do one thing. Let me just share this video with you guys. I think this current sessions, this particular sessions video, it will convert after a very long time. Yeah.
Vishnu, just wanted to check on one thing. So, in case there is a, as we said, that a session which performs a commit or issues a commit for a block that has already been pushed onto the disk by some other flush or anything else. Now, in that case, so the query is, as you said, that a select would, generate redo. That is pretty much evident, but the select would generate the redo only when there is the ITL would be cleared, or as we understand.
ITL is cleared.
Okay. Before that, there is no redo.
No redo. So it is only when you have an open ITL slot, then only you will end up generating the redo base. So you need to be very careful when you're troubleshooting stuff such as this. You need to be very.
I have a question. So in order to do the select also, it needs the open ITL slot, right? So it should need the right for the select statement also.
For when performing a select statement, all the ITL slots should be closed. The best case scenario is when you are performing a select statement, the ITL slot, you don't require an ITL slot for a select statement. The ITL slot is required only if you want to modify the contents of the block only. That is only required when TML statements are run. So get it?
I got it.
So select statement does not require adding the entries there. It just cleans up the ITL record, especially if you have one open.
But it does CR fabrication, right? So
Yeah.
during that time, so how does it manage the ITL slot in the block?
CR block information, CR block, when you're fabricating a CR block, so I'll put it in a different sense. So let me just bring this thing here. So one moment, guys. I don't know why my pen is not working. I think everything is falling apart today. So the hell. So I'm gonna share this other screen now. So cleaning up the generating a CR block. What you do, you clone the block, right? Everyone?
Yes, sir.
You apply the
Yes.
rollback information. You apply the rollback information. So do you think redo will be generated here? Do you think redo is required to make these things?
No.
This entire mechanism is just for read consistency only. For read consistency only. So anyhow, you clone the buffer and you roll back the changes here on a CR block, CR or consistent read version of the block, which is generated to satisfy or to I'll put it in a different sense, to basically support your read consistency part only. So in this case, there is no need to generate redo. Redo is not generated. Do you get the picture?
Yes, sir.
Yeah, Vishnu. Thank you.
So anything else, guys?
Vishnu, just adding on, I'm sorry, we are actually lagging a lot, probably taking in your time. Just adding on to the last question that you said only when the ITL is probably cleared is when the redo would be generated. But just in case,
yeah.
I mean, is that understanding correct?
So redo is generated when you have an open ITL slot and the transaction is committed. This session has to mandatorily clear the ITL slot. Yes, for modifying the ITL slot information, Oracle does generate redo.
Irrespective of
that means
any
it will be
statement,
for
right?
the modification of the ITL, which basically
Yes.
so just in case if there's a delayed commit or delayed cleanout, basically, wherein just in case there's a delayed cleanout, wherein the
wherein the ITL?
Wherein the ITL is still not cleared,
Yeah.
Okay, in that case, if I mean this is literally, I probably might be getting very intricate with this, but then in case there's a sort of a crash, we actually do not know whether the ITL was ever cleared or not. It is only upon checking the disk version of the block is when we understand.
Yes.
So we do not have a redo for such a block that might, I don't know, might probably lead to some sort of corruption.
Redo will be there. So I'll put it in a different sense. You are not looking at things in a different perspective. So redo for every DML will always be there on your redo logs. So you are combining the recovery part, instance recovery part, and also the transaction recovery part, entire thing into one place.
Okay.
You're adding all these things into one part. I mean, these are not required. These are not required in I'll put it in a different sense. The scenario wherein, and moreover, the corruption due to the recovery, as a part of recovery, yes, there are several bugs, but normally speaking, you don't see that one. Even the instance recovery and moreover, post instance recovery, it can also trigger a transaction recovery as well. So that is a different story altogether.
No problem. Thank you so much.
And one more thing, whenever redo is getting generated, so same time undo also will generate.
Yeah, when you are doing a block modification, undo is also generated, right?
Will like delay cleanout will have Aura 155 error, like I have read in the book. That's the
Yeah,
reason.
it can under certain circumstances. It can under certain circumstances. And let me stop the recording for now.